Hello, I'm Guampil, and today we will be taking a look at competition 12516, sprint number 11. The question says, Mark has 35 frogs and 65 toads. When he hears a toad, there is a 90% chance that he will correctly identify it as a toad, and a 10% chance that he will say incorrectly identified a frog. When he hears a frog, there's an 80% chance that he will correctly identify as a frog, and a 20% chance that he will incorrectly identify as a toad. Without looking, Mark randomly chooses one of his animals, listens to it, and identifies it as a frog. So what is the probability that it is actually a frog? Express your answer as a common fraction. So let's just organize this data a little bit. He has 35 frogs and 65 toads. When he picks a frog, there's an 8 in 10 chance that he correctly identifies it, and a 2 in 10 chance that he incorrectly identifies it. So out of these 35 frogs, 7 of them will be identified as toads, and 28 of them will be identified as frogs correctly. And for the 65 toads, there's a 9 in 10 chance that he correctly identifies it as a toad, and a 1 in 10 chance that he incorrectly identifies it as a toad. So 1 in 10 chance, that's just 65 divided by 10. So 6.5 of the 65 toads will be identified as frogs incorrectly, and then the remainder, 58.5, will be correctly identified as toads. And to solve this problem, what you need to know is something called Bayes' theorem. And Bayes' theorem is the probability of event A happening given that event B happened is equal to the probability of event B happening given that event A happened times the probability of event A happening divided by the probability of event B happening. And in this case, we want to look at what is the probability that Mark picks a frog given that Mark hears a frog, right? So, and this will be equal to the probability of Mark hearing a frog given that Mark picked a frog times the probability of Mark picking a frog divided by the probability of Mark hearing a frog. So the probability of Mark hearing a frog given that he picked a frog. So we're assuming that he picked a frog in this instance. So we're only looking at this top case over here because we are assuming that he picked a frog. And the probability that he hears a frog is just 8 over 10. Now, for probability of Mark picking a frog is we are looking at this case over here, and that's 35 frogs over the total number of frogs plus toads, which is 100. And the probability of Mark hearing a frog is, so there are 100 total toads plus frogs, and then the probability that he hears the frogs are in the cases where he hears the frogs are these two cases over here. So add those together and then you get 34.5 over 100. So now we can just use this formula over here and then get 8 over 10 times 35 over 100 divided by 34.5 over 100. Now I'm just going to simplify this and multiply 2 to both the numerator and the denominator in the bottom fraction to get rid of that decimal place. So I get 8 over 10 times 35 over 100 is equal to 69 divided by 200. Then I'm just going to simplify this top case a little bit here. Turn 35 over 100 into 7 over 20. And then divide 69 over 200. And they get 56 over 200 divided by 69 over 200. And then we can see that these nicely cancel out. So we get our final answer of 56 over 69.
Hi everybody, this is Tim. Hope you're enjoying our videos. If so, you know what to do: like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.